You check your phone before you walk outside, not for messages, for the UV index. A number tells you whether today is the kind of day your skin needs protecting from. But the real answer to why your skin looks the way it does is far stranger than sunscreen. It starts almost 2 million years ago on the open grasslands of Africa. Your earliest ancestors were losing their fur. Their bodies were built for endurance, for chasing prey across long, hot distances. And a furless body under a tropical sun needs protection, so evolution gave it protection. Dark, dense melanin. Melanin is just the pigment that colors skin, hair, and eyes. More of it means more shielding from ultraviolet radiation. Less of it means more UV gets through. For nearly all of human history, dark skin was the default, not a variation. The baseline, the anthropologist Nina Jablonski, along with her colleague Chaplin, mapped this out in a landmark 2000 study. Jablonski and Chaplin proposed that skin pigmentation is evolved primarily to regulate the effects of the sun's ultraviolet radiation on key nutrients, important for reproductive success. 2 nutrients in particular. One that dark skin protects, one that light skin unlocks. Here's the first one. Folate. Folate is a B vitamin your body needs to build DNA and support healthy pregnancies. And here's the strange part. Strong ultraviolet light can break folate down in the bloodstream. In a place with intense year-round sun, that's a real danger, especially for pregnancy. Low folate is linked to serious birth defects. So dark skin, rich in melanin, acted like an internal sunscreen. It kept ultraviolet rays from destroying a nutrient your ancestors couldn't afford to lose. So, if dark skin was protective, why did anyone lose it? This is where the story turns. Around 70,000 years ago. Groups of humans began leaving Africa. They moved north into Europe and Asia, and they walked into a different sun entirely. Weaker, lower in the sky, filtered through thicker cloud cover and longer winters. The UV radiation that once threatened folate was no longer abundant. It was scarce, and scarcity created a new problem. Vitamin D. Your skin doesn't just block UV rays. It also uses a specific band of them to manufacture vitamin D, a nutrient essential for absorbing calcium and building strong bones. In a high UV climate, this is easy. Even heavily pigmented skin lets enough sunlight through. But in a low UV climate, dark skin becomes too effective a filter. It blocks the very rays needed to make vitamin D. The result over generations was a nutrient deficiency. Weak bones, rickets, fertility problems. So the same trait that once saved lives began to cost them. Evolution had a new problem to solve, and it solved it the only way it can slowly. Through the survival and reproduction of whoever happened to carry a rarer trait, lighter skin. Skin that let in more of the weak, scarce sunlight and made enough vitamin D to survive a northern winter. This is what scientists call the vitamin D hypothesis, and it explains something that used to puzzle researchers: why light skin evolved independently in Europe and in East Asia through different genetic paths converging on a similar outcome. Different mutations, same pressure, same solution. Now here's where genetics gets involved directly. One gene stands out above the rest, SLC24A5. It sounds technical, but the idea is simple. It's a gene involved in how pigment cells produce and distribute melanin. A single mutation in this gene has an outsized effect on skin tone. Researchers, including a team led by geneticist Keith Cheng, identified this gene's role by studying zebrafish, whose pigment mutations mirror the ones in humans. And when Cheng's team looked at human population, they found something remarkable. This particular version of the gene is present in the vast majority of Europeans, and it is nearly absent in Africans and East Asians, who lightened through separate genetic routes involving different genes entirely, like OCA2 and KET-LG. Different populations, in other words, ran the same experiment. And nature found more than one answer. But here's the twist, the one that upends what you probably assumed. You'd expect this transition, dark to light, to be slow and gradual. A dimmer switch, turning down over tens of thousands of years as people moved further from the equator. That's the story most people carry around. It's a story that feels intuitive. It's wrong. In 2015, a team led by geneticist Iain Mathieson analyzed ancient DNA from dozens of skeletons across Europe, spanning thousands of years. Their goal was to catch evolution in the act by comparing genetic variants across time. And what they found was startling. The genetic variant that codes for depigmentation at SLC24A5 was almost ubiquitous in early farmers throughout Europe, but was still not fixed in populations of Iberia and Hungary by the mid-Neolithic, meaning it hadn't yet spread through the whole population by that point. Even more surprising was a discovery from Britain, a nearly complete skeleton known as Cheddar Man, roughly 10,000 years old. Researchers from the Natural History Museum in London, working with University College London geneticist Mark Thomas, sequenced his DNA and found something nobody expected: dark skin, not light skin. In Britain, just 10,000 years ago. Pause on that for a second. 10,000 years is nothing in evolutionary terms. A blink. And it means that light skin, the trait you probably think of as ancient and unchanging in Northern Europe, is actually one of the newest features of the modern human body. It didn't arrive with the first migrants into Europe 40,000 years ago. It arrived later, much later, spreading through population after population, gene by gene, well within the time frame of farming, pottery, and early agriculture. Why does that matter? Because it means skin color isn't some deep, ancient marker of identity, fixed since time immemorial. It's closer to a fast-moving adaptation, a biological improvisation still being written when your ancestors were already building settlements. Evolution wasn't finished with human skin color by the time humans were finished being nomadic hunter-gatherers. It kept working. It's arguably still working now, in the sense that this trait remains one of the most variable, most recently changed features across human populations. There's another twist tucked inside this one. Diet played a role too. Once agriculture spread, human diets shifted heavily toward grain. Grain-based diets, unlike the fish and meat common in earlier hunter-gatherer life, are low in vitamin D. Fish, in particular, is naturally rich in it. So a population living along the coast, eating fish, has less pressure to lighten. A population that moves inland and switches to farming loses that dietary source of vitamin D. Suddenly, the skin has to do more of the work. Suddenly, lighter pigmentation becomes more valuable because it's the only path left to synthesizing enough vitamin D from weak sunlight. This is why some coastal and Arctic populations, like certain indigenous groups in the far north, kept darker skin despite living in low UV environments. Their diets, rich in fish and marine mammals, supplied vitamin D directly. Their skin didn't need to change because their food already solved the problem sunlight normally would have. Every piece of this story, in other words, is a trade-off, not a march towards some better skin tone, not an upgrade. A negotiation between three forces: protecting folate, producing vitamin D, and whatever the diet already supplies. Different environments demanded different negotiations. And your ancestors' skin color today is the settlement that negotiation reached generations ago in whatever landscape they called home. So what does this have to do with you scrolling through a weather app, deciding whether to bring sunscreen? More than you'd think. You're still living inside this ancient negotiation. Every time you check the UV index, you are unconsciously managing the same trade-off your ancestors managed biologically. Too much sun. And there are modern risks, skin damage, and increased cancer risk, especially for people whose ancestors adapted to lower UV environments and never needed heavy pigment protection. Too little sun. And there's a quieter, modern epidemic: vitamin D deficiency. Now common across much of the world, largely because you spend your life indoors, under artificial light, dressed in clothing your ancestors never wore. You've essentially recreated, through architecture and lifestyle, the same low UV problem that once reshaped the genome of an entire continent, except now it isn't slow evolution solving it. It's a vitamin D supplement picked up at a pharmacy, standing in for 10,000 years of natural selection. There's something almost humbling in that. The same biological tension that took millennia to resolve through genetic change, you now resolve with a pill, a food label, a doctor's recommendation. What used to require deep time now requires a trip to the store. And there's something else worth sitting with. The visible traits so many human societies have organized so much meaning around, so much hierarchy, so much identity, turns out to be one of the most recent, most fluid, most environmentally reactive features of the human body. Not a fixed marker of ancient lineage stretching back to the dawn of humanity. A dial that's still being adjusted, biologically speaking. In geological terms, it barely finished adjusting at all. Skin color feels permanent because a human lifetime is short, and a single lifetime never sees it change. But zoom out the way ancient DNA now lets researchers do, and you see something closer to the truth. A trait in motion, reacting to migration, to latitude, to diet, to millennia of quiet pressure from ultraviolet light and the nutrients tangled up with it. Your ancestors moved into new landscapes, and their bodies followed, adjusting the one visible trait most exposed to the sky above them, slowly. Then, in Britain's case, almost recently enough to feel abrupt, a dark-skinned hunter-gatherer, standing on ground that would one day become England, just 10 millennia before your own lifetime. You check the UV index before you walk outside, but it isn't really about avoiding sunburn. It's the same conversation your ancestors' bodies have been having with the sky for 2 million years. You've just automated your side of it with an app instead of a mutation.